Hello, myself Shushmit Chakraborty. I am here to teach you the electrical machine 2 subject. Here code is PC EEE 501. Third year EEE branch or cell. Okay. So here this is the electrical machine 2. So let us start first syllabus, then I will teach you the topic day by day. So first introduce the syllabus. So first one is fundamental of AC machine winding. So in your syllabus, the first chapter, module 1, your module 1 is fundamental of AC machine winding. Fundamental of AC machine winding. So this module consists of various type of windings. Those are present or those are used in AC machine. Okay, so basically this chapter is basically the basic chapter. When you are in previous semester, that is when you are taking your class from the machine 1, then you can see that the winding are also some windings are there. You have learned some winding concept. So here the same thing, but before start the detail in machine, so first module is that fundamental of AC machine winding. Okay, so second module number 2. So your module number 2 is magnetic fields, different magnetic fields. So here actually magnetic fields means the basic operation of this electrical machine. We know, all of us we know that the electrical machine, actually what is the electrical machine does? Either electrical energy to mechanical energy or from mechanical energy to electrical energy. So this is nothing but the electromechanical or electromagnetic system. Electric machine is nothing but an electromagnetic system. Okay, so where the rotation or the electrical energy or the mechanical energy is produced. Okay, so this most important concept is the magnetic field. How the magnetic energy is associated to any particular machine. Okay, so this is the most important chapter. So these two are the basics of your machine 2. Okay, so after this module 2, so module 3 is, this is the important and this is the detailing chapter module. This is a 3-phase. Phi means the phase. Okay, phi represents the phase. Okay, 3-phase synchronous machine. So this 3-phase synchronous machine, 3-phase induction machine. So first you have to learn 3-phase induction machine. Module 3 is in your syllabus. Module 3 is 3-phase induction machine. So 3-phase induction machine. What is a 3-phase induction machine? So it is very much important. I think when you are in semester 2 or 1, that is 1 I think. At that semester you have learned a subject that is basic electrical, right? So this basic electrical consists of a 3-phase induction machine. So in your practical also there is a practical for 3-phase induction machine. So 3-phase induction machine, I think you have already learned something, okay, about the 3-phase induction machine. So for this class, that is third year, so you have to learn in detail. Okay, you have to learn in detail 3-phase induction machine. So this is the important module. Okay, so module number 4. Fourth module is single phase induction machine. Single phase induction machine. So basically 3-phase induction machine is motor. Okay, and similarly it is also a motor. So motoring mode also present in case in case of your syllabus. Okay, so actually generator, three-phase induction generator is rarely used. Okay, so single phase, that does not sense anything. Okay, so single phase induction motor is very much important chapter also. So module number 5 in your syllabus, this is synchronous machine. So synchronous machine both have motoring part and generating part. Okay, so what is motoring part, what is generating part, I will discuss in later when we go when we reach the module number 5. Then we can learn that the synchronous machine has two types of operation. That is, the first one is motoring operation, second one is generating operation. So these are the concepts, then I will teach you later. So module number 6. Okay, so this last module, this is the 6th module, last module, special type of machine. Special machine. So this special machine consists of 6 or 7 machines. Okay, so reluctance motor, permanent magnet motor, brushless DC motor, hysteresis motor also there, tacho generator, stepper motor. These are the concepts. Actually, special machine is nothing but the combination of these three. Okay, special machine is nothing but a combination of these three and also DC type. Okay, so see, these two are the basic chapter. These two are the basics for electrical machine. Okay, and these three are the applications for electrical machine. Okay, and special machine is the exception or special type of machine. Okay, special type of machine. So when in your syllabus you can see that the fundamental of AC machine winding, this is the basic, actually the basics of your electrical machine. So I think it will require how many classes. So now I am writing the number of classes required. Okay, so today actually we have make a plan how to reach the ultimate semester. Okay, ultimate final semester. So fundamental of AC machine required, I think 6 classes. Okay, 6 classes. So next, different of magnetic fields. This is actually nothing but the concepts of these three. So I think it will need 2 classes, maximum 2 classes. Okay, so 3-phase induction machine, it is the very much important. It needs most approximately 10 to 12 class. So I will write 12 plus maximum. Okay, I will take the maximum. Okay, single phase induction motor within 8 or 10 days, I think you can easily complete it. Okay, so synchronous machine, it requires more or less 14 days, and special machine, I think within 2 days we can complete. Actually, this special machine, from this special machine we have to learn the short note based question answer. Okay, so I will give you the note for this special machine, and there is a small some amount of concept we have to understand in this live class. So special machine requires 2 days. So how many number of days are required total? 16, 26 and 10, 36, 38, 38, 40, 46. So more or less 46 classes. So more or less 46 classes are required. So 46 class means how much? That is a week consists of 4 classes. So 10 weeks, 12 weeks, approximately 12 weeks. So 12 weeks are required. Okay, so day by day I will reach the end of the syllabus. So today I will give you some important concept. Okay, so what is the important concept? So basic thing you have to learn, or pre-requesting concept, actually you have to learn by yourself. So these are the first thing. To learn this syllabus, we have to clear some basic idea. So what are the ideas? Idea is that you have to first learn the circuit theory based concepts, that is Ohm's law. Next day I will I have detailing. I will teach you the detail in detail. So today I am giving you some topics which you have to learn within this week. Okay, within this week, not within before the next day. Okay, so Ohm's law, then KCL, KVL. Okay, this concept you have to first understand. Then one, equivalent circuit. Okay, equivalent circuit of any network. Equivalent circuit of any network. So next one, RLC response in DC. Next one, RLC response in AC. Phasor concept and diagram of phasor. That means phasor diagram. Okay. And next one, vector concept and EM theory. Okay. So these are the concept. EM theory means the formula. That is the Faraday law, Lenz law, Biot-Savart law, Ampere-Circuital law. These type of laws you have to learn. Okay. So these are the topics. It is before entering the electrical machine 2, you have to learn this one. Okay. So today I think there is a time. So I think about this syllabus. Okay, so today I will start the fundamental of AC machine winding. Okay, so today I will start the fundamental of AC machine winding. So make it tedious. Okay, so before entering into this topic, fundamental of AC machine winding, first you have to learn what is AC machine. What is AC machine? What is the difference between AC machine and DC machine? Actually, AC machine, what is AC machine does? AC machine means a alternating source of current or voltage is directly associated with the system. So a system where alternating source of energy is getting input to the system. This is the system. It may be single phase induction motor, it may be three phase synchronous motor, it may be three phase induction motor. Okay, this one, and we give the desired or only output in the basis of electrical energy or mechanical energy. If we consider it is a electrical energy, then it is a motor, system is the motor. And if we consider it is a electrical energy, it is the system is generator. And if it is mechanical energy, then it is motor. Okay, so alternating source of energy is given to the system. Okay, this is the main important concept. So AC machine means, so first understand AC machine classification. What is the AC machine classification? AC machine are of generally two types. Okay, AC machine are of generally two types: synchronous machine and asynchronous machine. Asynchronous machine. So what is synchronous machine and what is asynchronous machine? We can understand in detail after completing this topic. Just wait. I will in next few classes I will discuss. Okay, so in synchronous machine and asynchronous machine, in asynchronous machine is called induction machine. Okay, So synchronous machine are of two types: synchronous generator called alternator and synchronous motor. Okay. And induction motor are of two types: single phase induction motor, IM means induction motor, and three phase induction motor. Okay, so single phase induction motor is in your syllabus, detail you have to study. Three phase induction motor you have to in your syllabus, detail you have to study. Synchronous generator and synchronous motor, these four are in your syllabus. So AC machine 2 consists of these four electrical machines. Okay, and some important special machines. Okay, so just one statement I will give you, that is the synchronous. What is synchronous generator? First thing, synchronous generator, a primary source of electrical energy. Synchronous generator means a primary source of electrical energy consisting three phases. A primary source of electrical energy, that is, it generates electrical energy and it consists of three phases. Okay, and synchronous motor means what? This synchronous motor actually used as motors as well as power factor compensator. Always mind it, power factor compensator or synchronous condenser. Synchronous condenser or power factor compensator. What is power factor compensator? I think what is power factor? I think you know, right? Power factor means, what is the power factor? So power factor means the active power divided by total power, right? Power factor cos theta equals to active power by total power. What is the active power? I square. What is total power? I square z, right? So I square will cancel out, r by z. So cos theta equals to r by z, and we know z equals to what? Impedance, r square plus x square. It may be xl or xc. Okay, so cos theta equals to this one. So if we consider the power triangle and impedance triangle from the same way, we can assume that it is r, it is x, and it is z. So this is your theta. If we consider, if we apply cos theta over here, so base by perpendicular, base by hypotenuse, that is r by z. So r by z your cos theta. This is the power factor. So power factor compensator means we have to reach the power factor unity. Okay, so power factor compensator means whenever the power factor falls down, then power factor will be corrected by some amount. Okay, so this synchronous motor do some this concept. Okay, synchronous motor is that is a synchronous motor. Okay, so next one is asynchronous machine. So asynchronous machine means single phase induction motor. Actually single phase induction motor, actually these three phase induction motor and single phase induction motor are nothing but the same types of operating principle, but in case of single phase the energy power conversion is smaller compared to three phase induction motor. Okay, in case of three phase induction motor there is a huge amount of high rated system. In case of high rated system, three phase induction motor is used. And in case of low rated system and in case of low rated desiredness, so single phase induction motor is required and used. So in your home and domestic purpose, the overhead fan means what? Overhead fan? Ceiling fan, right? The ceiling fan is nothing but a single phase induction motor. Actually single phase induction motor there are different classifications. So when we are reach to the single phase induction motor in detail, then I will discuss here there are some classifications are there. So it will be better to leave some portion over here. Okay, so after completing one by one chapter, we are make a classifications over here. So leave some area of your copy. Okay, so induction generator actually, so they see here the synchronous machine means generator and motor, and here the asynchronous machine means in single phase induction machine, and they are all motor based. Okay, why motor based? Because actually due to lack of a separate field excitation, due to lack of a separate field excitation, the machines are rarely used as generator. Always remember. Why? Sometimes in your interview board this type of question may be asked, that why the asynchronous machine does not act as a generator, and why induction machine does not act as a generator. Why? Because due to the lack of excitation system. separate field excitation system. Okay, so this is the important concept, basic concept of AC machine. And after that, then we have to learn energy conversion. Okay, what is energy conversion? Next topic is under this energy conversion heading. So note something. Okay, I will discuss one by one. Generators convert mechanical energy to electrical energy. It is very much clear. Generators convert mechanical energy into electrical energy. So first point, generator converts mechanical energy to electrical energy. So this mechanical energy, what is the mechanical energy? Mechanical energy is made by prime mover. What is prime mover? It may be diesel engine, it may be turbine. These are the prime movers. Okay, and what is electrical energy? Electrical energy is nothing but balanced three phase, balanced single phase. These are the, okay, it is a balanced three phase system or single phase system. Okay, so this is first topic, the energy conversion. Generator converts mechanical energy into electrical energy. Okay, then the motor converts electrical energy into mechanical energy. So this mechanical energy is nothing but a wind. That is, in case of your ceiling fan, there is a wind, right? Or in case of submersible pump, there is a suction, right? There is a suction. If there is, in case of drop through FD IT fan, there is a suction as well as the compression. Okay, so these are this type of motors are there. Okay, so electrical energy and mechanical energy are same types. Okay, so next one, third point, right? The construction of motors and generators are similar. Always remember, motor and generator both have motor and generator both have identical characteristics in from the point of view of construction. That is, it has a stator, so a system, another system. So this is a stator, this is rotor, or maybe this is rotor, this is stator. Okay, so there is a stator and rotor, there is a rotor and stator. So these type of concepts are same. Okay, so from the operating principle they are different, but the construction, in case of construction features, they are same. Okay, so fourth point, right? Every generator can operate as a motor and vice versa. Every generator can operate as motor and vice versa. Always remember. Okay, and there are some important equations are there, right? For generator, mechanical power equals to, for generator mechanical power. Why mechanical power? This is the input energy. Mechanical power equals to electrical power plus losses. So there is a loss, right? So mechanical power equals to electrical power plus losses. And in case of generator, and for motor, what? For motor, electrical power equals to mechanical power plus losses. Okay, so these are the basic equations, and now these are the basic concepts. Okay, so now we are going to teach you in detail the AC winding design. What is AC winding design? Okay, now AC winding design. The winding, what is winding? Windings used in rotating electrical machine can be classified as, so winding classified into broadly two categories. First one is concentrated winding. Second one is distributed winding. Okay. Similarly, AC machine winding are also classified as, again two types: open type winding, closed type winding. Just write the classifications first. Next day I will discuss in detail for every classifications and with some example. Okay, so these concentrated, distributed, open type, closed type, these are four types of windings, four different classifications, and after that we will understand the concept step by step. Okay, so today class 1, okay, this is your first class, class 1, first class, okay. So next day I will teach you in detail of these winding designs and give some important examples of each of the winding design and discuss some important topics and terms which are related to this winding. Okay, like coil span factor, pitch factor, some important ratios are there, some constants are there. Okay, so today class up to this much. Thank you and follow the classes regularly. Okay.